What we're looking at right here is the final stop on an absolutely epic journey. We're about to unbox a package that traveled billions of miles over 7 years, and it's carrying a message from the very, very beginning of our solar system. This is the story of the pristine samples from Asteroid Bennu, and you won't believe what they're telling us.
And when I say unboxing, I mean that literally. This isn't just any old rock. This is a cosmic time capsule, packed with the original ingredients that built every single planet, including our own, over 4.5 billion years ago.
So after a 7-year, 4 billion-mile trip, the OSIRIS-REx mission delivered its precious cargo. What you're seeing here is material that's been perfectly preserved, completely shielded from Earth's atmosphere. This is, hands down, our most direct look ever at the raw stuff that built our solar system.
So what is it that makes this special delivery from the cosmos so scientifically priceless? Let's break it down.
First, let's meet the source of all this excitement, Asteroid Bennu. Now, Bennu isn't a solid rock, it's what scientists call a rubble pile. Just imagine a huge planet-like body getting shattered in a cosmic collision billions of years ago. Then, some of those pieces slowly, gently clumped back together. That's Bennu. And that means every little piece on its surface is a clue to the history of its ancient parent.
So here's why this sample is just so revolutionary. Unlike meteorites that we find on Earth which have burned through our atmosphere, this material is completely untouched. It hasn't been contaminated by our planet's water or its air or any life. In short, it is the purest, most pristine sample of the early solar system humanity has ever gotten its hands on.
So the big question is, what exactly did scientists find when they so carefully opened up this cosmic time capsule? Let's take a look inside.
Well, the sample is a complete scientific treasure trove, holding a mix of clues that almost seem to contradict each other. We see water-rich clays right alongside minerals that formed in really high heat and never saw water. We see primordial organic matter, and most incredibly, they found literal stardust, grains from stars that existed before our sun was even born.
Okay, let's just pause on that last one, pre-solar grains. Think about what that actually means. These are microscopic specks of literal stardust, forged inside stars that lived and died before our sun even existed. They are true messengers from a time before our time. It's just mind-blowing.
And this isn't some theory. Scientists actually found them. Specifically, they found these ancient silicon carbide grains at an abundance of about 25 parts per million. Now, that might sound absolutely tiny, but finding even that amount is like a cosmic detective finding a perfect fingerprint at a crime scene. It is a massive clue.
So how in the world do you find a single grain of ancient stardust? Well, as you can see here, scientists use this incredible technique called isotope mapping. Because these grains were born in different stars, they have a unique chemical signature, sort of an isotopic glow. By mapping these isotopes, scientists can literally make these tiny, ancient treasures light up, revealing exactly where they are inside the sample. It's a cosmic treasure hunt.
And the fact that these ancient, unaltered grains exist at all, well, that brings us to the central mystery of Bennu. Its surprisingly watery past.
You see, the overwhelming majority of the sample is made of hydrated minerals, stuff like clays. And this is the smoking gun. It tells us that Bennu's huge parent body was once a wet world. Billions of years ago, ice trapped inside it melted, and liquid water percolated through the rock, chemically altering almost everything it touched. But that raises a really fascinating question, right? If this asteroid was soaked in water for ages, a process that normally destroys delicate materials, how on Earth did fragile things like presolar grains and pristine organic matter survive at all? The answer, as this chart kind of shows, lies in preservation. Imagine the main body of the asteroid being cooked by water, creating all those altered clays and minerals. But locked inside, like tiny time capsules within the larger one, were pockets of the original material. The stardust, the water-free silicates, the water just never reached them. Their survival is proof that the transformation, while it was extensive, wasn't total.
So let's trace this incredible history from the beginning. It starts before our solar system, with ancient stardust floating in space. That dust gets swept up into a large, ice-rich body over 100 kilometers wide. Then, internal heat from radioactive decay melts that ice, turning the inside into a wet, geologically active world. And then, bam! Disaster strikes. A massive collision shatters the entire body. And from those fragments, Bennu is eventually born, a new world reformed from the rubble.
This completely unique history gives Bennu a distinct chemical recipe, even when you compare it to its closest cosmic relatives.
To put it simply, Bennu just has more of the really good stuff, the oldest, most primitive materials. It's richer in these unusual organics and the water-free minerals than samples from its closest cousin, Asteroid Ryugu, or any similar meteorite we've ever found on Earth.
And you can actually see this unique chemical fingerprint in its isotopes. This chart, for example, is looking at a specific type of titanium. It shows that while Bennu, Ryugu, and a related group of meteorites clearly share a common origin, they're from the same cosmic family, you could say, Bennu's signature is the strongest, the most distinct of them all.
This table here puts the key differences in really sharp relief. When you compare it to Ryugu, Bennu has way more of the original unaltered materials. This points to one of two really fascinating conclusions. Either Bennu's parent body started with a more primitive recipe, or it just wasn't cooked in water for as long or as intensely as Ryugu's was.
So, what does all this mean for the bigger picture? How does this one rock rewrite the entire story of our solar system?
Okay, here it is, the big reveal. The giant cloud of dust that formed our solar system, it wasn't a uniform, well-mixed soup. It was lumpy. The fact that both Bennu and Ryugu even exist proves that bodies forming in the same general region could be built from very different recipes.
So Bennu confirms that the early solar system was this messy, diverse construction zone with different ingredients available in different places. Evidence suggests its parent body formed way out, maybe even past Saturn, and it captured this unique water and organic-rich mix of materials that, somehow, against all odds, has survived for us to study today.
This single sample has opened up a brand new window into our own origins, revealing just one lost recipe from the dawn of our solar system. And it just leaves us with this thrilling thought. How many other unique planetary blueprints are still out there, locked away in other asteroids, just waiting for us to go find them?